Hello, everybody. Thank you for joining us for RMUS Tech Week. This is our third session of the week, and we'll be focusing on digitization of the mine, which is a big topic which probably deserves some qualification. We'll get to that later. We have a very illustrious panel of industry experts with us today, and I'll allow each of them to introduce themselves to you in just a moment. My name is Fraser. I'm the Director of Tech at RMUS Canada. I'm kind of the chief nerd here, and I get to, fortunately for me, go to lots of mines and play with our technologies that we're going to be talking about today. So for now, let's start with you, Anthony. Could you tell us a little bit about your role, who you work for, what you do with technology, and what you hope to get out of it?
Sure, no problem. Hello everyone. My name is Anthony Downs. I live in Austin, Texas. I work for Vale. I am one of their leaders in the Global Innovation Group. Um, it's a little bit different to other mining companies' innovation groups that we focus on big problems a company has where there are no obvious solutions available. So we go out and we network with peers in mining, space, heavy industry. We go out and talk to academia. We go out and talk to entrepreneurs, and we either find a solution that will work or we'll end up building one ourselves. I work with customers internally in both underground in Canada as well as the open pit in Brazil. And prior to Vale, I had a whole heap of different operational and technical roles with Rio Tinto across a number of different countries. So that's me.
Thank you, Anthony. Ian, if you could introduce yourself, please.
Yeah, hi everyone. I'm Iain McKillip. I'm the manager of mine technical for kit operations in Northern Ontario, Timmins area, um, and we're an ultra deep mine. So a lot of our applications and technology surround being able to work at that kind of frontier and conduct business in that highly unusual environment, and we've had to find unique ways to work around some of those challenges using technology, remote systems, digitization, and so on. So that's where that's where our background came from, and where my background is. I am a mining engineer, and look at a lot of the applications that work through that piece of the puzzle. Let's say.
Awesome. Thank you. So, Matt, this is, of course, not your first time joining us. Always happy to have you. Could you please tell us a little bit about yourself?
Yeah, hey everybody. I'm Matt Mackinnon. I'm the owner and founder of Unmanned Aerial Services. As far as myself, I kind of tie into everybody in this group, and that we're a service provider. So we've worked with Anthony and Ian and Raffi, along with a whole bunch of other groups. So for us, we provide solutions to an industry that seems to be all they have is problems at some times. So we just provide remote access into those areas. So all those hazardous areas that they can't get into, we have just a whole different suite of tools that we use to access those problems and get them information so they can make better, more informed decisions.
Sounds like a lot of fun. Thanks,
Cool
Matt.
job.
Uh, Raffi, if you could please tell us about yourself and your role and what you do with technology.
Sure, thank you. Um, so my name is Raffi, and I am the Vice President of Commercial Sales and Business Development for Exyn Technologies. My background is in mining. I spent about 10 years with Dundee Precious Metals in various roles in Armenia, Africa, Bulgaria, and then back to Toronto, where I'm currently based. And Exyn Technologies is a spinoff from the University of Pennsylvania, basically working with autonomous robots, namely specifically drones and some ground-based vehicles. And the big thing for us is capturing data in hard-to-reach areas. A lot of the things that Matt and team do, and I think our number one goal is, which I think both Anthony and Ian could talk to as well, is just getting the miners home safely. So if we can do things a little bit more efficiently, and at the same time get things done a little bit more accurately, then we've done our job.
Awesome. Great. Thank you. So, of course, our topic for discussion today is digitization of the mine. In one way or other, this is a process that's been underway for a long time now. Different parts of the process and mine management have certainly been digitized for some time, but it's an ongoing process. So today we'll be talking about this mainly in the context of scanning technologies and in particular remotely operated systems. So if I could just sort of pose this question to you guys broadly, what is really driving the current trends in this process? Is this mainly about the availability of new technologies? Is it new demands from the industry, or is it something else entirely?
I'll just jump in quickly because I'm think there's a couple other people in the room, mainly Anthony and Iain, that could probably speak better to this. But it's the depth of the mines. They've stretched a lot of the shallow ore bodies as far as exploratory is concerned, and new developments, and a lot of the stuff is deeper, and that's kind of where Iain and Anthony and them both fall into place because they both operate in mines that are getting there in depth, and operationally it's quite difficult. So to have men down in these places doesn't necessarily make sense, and they just can't function in a lot of these places. So to be able to mechanize it as much as we can, but to have reliable mechanization is kind of what's driving it as far as I'm concerned.
So I'll
Yeah,
just
I
add to
mean,
that a little
sorry.
bit. As mining gets more complicated, we really want to be making more and more data driven decisions. We don't want to make assumptions. We don't want to make decisions on incomplete data, and sometimes we need to, but wherever we can, we really want to go in and find out the facts, have a high level of situational awareness, and then make the right decisions, whether it's a tactical decision or a strategic decision. And we really don't want to put our operational colleagues in harm's way to get that data. So if we can send a drone or a robot or some sort of sensor in to improve that situational awareness to get access to that data, then from my point of view, that's a no-brainer.
Yeah. I mean, you have to you have to remember with the mining industry that there's sort of two counter um, two aspects to it, right? Mines are getting more complicated and challenging as time moves on, but Anthony's getting at the other piece too, which is that standard of risk acceptability and our ability to work safely has gone leaps and bounds in heavy industry. And mining's gone from being one of the worst to one of the best in terms of safety records, and those tools that we use to achieve that overlap in the same space. So dealing with more complex mines and being able to do so safely, those are two things that have pushed us into trying to find new ways of doing things and new tools to bring decision making to a higher level.
Yeah, and more or less echoing all those sentiments. And I mean, the trend for technology companies like ourselves are definitely being driven by the miners. I mean, I was at the Sudbury office, Vale offices a few days ago, and literally, big letters, it says our purpose is we exist to improve life and transform the future. So I think the miners are telling you right there exactly what they want, and it's sort of on companies like Exyn and UAS to drive these things. But a lot of it's going to be on the return on investment aspect as well. It's how much value can we bring back to these miners, because we know the market is a little bit stretched at the moment, and even though some of the commodity prices may be doing quite well, nobody's throwing money around. So I think using technology to actually get a much larger return on investment is also one of the big things that are driving the current trends.
Okay, fascinating. So we've got technologies that are possibly cheaper than traditional methods, that are enabling really a data-driven situational awareness and decision making, that are providing this data as well as improving safety? And also maybe, I think you touched on, Matt, that maybe it doesn't make much sense to have people in these environments at all. Is this ultimately a drive towards complete automation? Is that what we're seeing? Can anybody comment on that?
I can comment from what I'm seeing. The direct automation thing. Everybody would love to have robots doing all the dirty, dangerous, dull jobs. The reality is that there will be no full automation in the full context of robots taking care of robots. You'll always have the human element of it involved because the decision making, we're seeing a lot of improvements with AI, like with ChatGPT and so on and so forth, but it doesn't have consciousness, right? So at the end of the day, to be able to make a decision based off of just your environment and your surroundings, not just off of the information that you see right in front of you, you're always going to have that human element to it. But the automation is absolutely necessary for a lot of these operations to be able to be in existence. So there's one operation in Sudbury, the Onaping Depth Project. Their whole plan, the whole way that this mine is going to work is banking on electric technology. So battery electric, if we don't have the leaps and bounds like we're seeing with the technology, this development, this mine won't go forward. So with all of that, though, it won't take away from humans. It'll actually help just make it a lot safer and a lot more efficient for them.
Yeah, and if I could jump in there as well. So I sort of agree with Matt. I don't foresee the day we're going to see a completely autonomous mine. Now, never say never. So maybe 50 years down the road, there could be something along those lines. However, in the short term, there's a lot autonomy can do for the mining industry. We still have a lot of downtime in the mines. For example, post blast when we're ventilating the mine, there's a lot of time down there where we don't have humans underground, where machines could be working. So once you get the remote actuation going, once you actually have machines that are working underground and sending data to the surface until it's ready for the humans to enter, there's a lot still to be gained. So I mean, automation and I still believe is in its infancy in mining, and there's going to be big step change here. I'd say anywhere in the next 3 to 7 years where we see major mining companies make changes during those downtimes.
Yeah,
Fantastic.
I was
Yeah,
gonna
go
say,
ahead, Ian.
we can't forget when we talk about automation in mining that the fundamental business case in mining has a unique aspect to it in that um, the it almost never makes sense when you look at a mining project to use automation as a savings opportunity, right? Um, the the there isn't a limited demand for the product that we're moving. There's a market, and really, if we go and make a huge difference in our production, it really isn't going to change the market. So that means in terms of dollars and cents in a mine design, adding automation, you're not going to save on people. You're going to use those people more effectively and increase your production rates or increase your cycle times and so on, because that is the driving um, that's the driving factor in the profitability of a mine. So we're gonna, see automation make, the crappy jobs better. Take the difficult pieces out of someone's job, turn it into something where they can, work in a really safe and clean environment compared to what we used to think of as mining, and use their expertise to interface or direct automation. At least that's the way that I see that uh, coming in.
Fraser, I liked what I think it was you said before, the dirty, the dull, and the dangerous. So work out what jobs we want our operational colleagues to do, and what jobs we can delegate to an intelligent piece of equipment to do. And like I said before, if we can get a robot to do a particularly dangerous task, then it's really on us to be using that technology rather than putting one of our colleagues in that dangerous situation.
Excellent. Excellent. So thinking about these future possibilities, what are the most exciting opportunities in this process of digitization? What new possibilities or outcomes are going to be the most meaningful?
So, for speaking as somebody who's doing it as a service provider, I think the biggest thing is just, and Anthony had touched upon this earlier, is the data. Being able to access these areas that traditionally it was all just guesswork. A lot of it that went into it. So to be able to have definitive information and then to be able to build better wear modeling in your bins, your chutes, all your areas that you do have to do constant rehabilitation on. I think a lot of that's where we're going to see like the biggest, I guess, increase in uptake of it. Because as far as like drones flying into stopes, that's pretty well defined. We have a good track record of them being able to, you set your waypoints, they fly in, they fly back out, you have your data. It's all the other difficult spots that are usually typically a lot tighter, a lot dustier, a lot wetter. Those are going to be the areas that you're going to see the technology taking leaps and bounds as far as being able to get people into these areas so they can make decisions before the project actually moves forward. So when it comes to planning a shutdown, for example, you can go into with a heck of a lot more information of knowing that we're going to be spending a week in an area as opposed to spending 3 weeks like we thought, if there's a bunch of scouring and blasting and drilling that has to go on. So I think that's where we're going to see the improvement, as well as visualization tools, I think, is the other big part of it. Because it's great to have all this data, but if you can't do anything with that data, you just have a bunch of storage drives full of ones and zeros. But if you can action upon that, and that's kind of the missing link that we're seeing right now. The technology, as far as hardware, is getting there. There's a lot of improvements that we're seeing on a regular basis, but it's a software that's really lagging behind, and it partially has to do with mining's kind of antiquated approach on problems. They're adverse to change, but it's coming from a good place where they've been burnt a lot of times by salesmen coming in, making big, bold promises of what the technology will do. So to be able to have the technology doing what it says it's doing, and then have those other pieces where you're having like your Deswicks, your I'm drawing a blank on all the different names, but there's a bunch. Having those people adopt 3D technology and 3D data, and then taking that and then putting it into a spreadsheet that a human then can go over very quickly and tell where the problem is, that's where we need big improvements. And that's what everybody's kind of working towards.
I think that's a big deal, because we've been as a company pushing for dense data collection, let's say, for quite a long time. If you would see our library of high density scan data, it's vast. It's beyond what we can handle with current tools. But that's transformed a problem. So it's transformed a problem of physical access into a that's very specific to mining, let's say, and it's turned it into a problem that makes sense to technology that's a little bit more non-specific, let's say. So if we have good data collection, we have remote data collection, we have regular data collection, we can put that information together, or that data together, and now we can use tools on it that are common to other industries. So tap into the experience that um, you know basically any organization that works with dense data can help us with. So we've made that big technical leap, I think, in making that possible, making it enabling the ability to bring in third-party analysis, to bring in AR, ML-based techniques for looking at that data and making it useful. Until we had that rich underlying data, those really weren't things that were even on the table. And I think we're just at really only scratching the surface of what we can do with it.
I agree. It's about processing the data and getting insights from that data, and being able to do that rapidly, and being able to do that with a high level of confidence. And I don't think both Matt and Ian are right. I think we're starting to solve how to capture the data. Now we start to need to think about how do we process it, how do we leverage it, how do we get the insights out of that data, to make those data driven decisions, and maybe over time to start to automate some of that decision making, starting to bring some expert systems in, not only to simply tell you that the level is 9 or the level is 8, but give you some context and give you some suggestions on what that means and what you should be doing next.
Yeah, definitely agree with the team here. I think, especially getting the data, and as Anthony mentioned, trying to automate some of it. So using things like robotic process automation to actually move things forward. We get asked a lot to put different sensors and different things on our robots, and it's fantastic to gather the data. And I think we've all heard the terms short interval control and digital twins being thrown around for years, but there's nobody who's actually mastered it yet. So as far as an opportunity is concerned, if we could use that data that we're gathering to create a real digital twin, and based on that, really start using RPA to get the data to be working for the mines and for industry at large, that's where I think the largest opportunity lies right now.
Really interesting. So each of you guys sort of touched on potential, in addition to the opportunities, potential challenges with working with these new technologies. So one of the obvious ones is there's just the sheer density of this data. So what is a sort of a typical reaction internally to the availability of these new types of data? Is it welcome? Is it accepted sort of begrudgingly? How significant are these challenges, and is that ever a barrier to adoption?
Well, I can go ahead.
Sorry, Matt. I was going to say there's levels to this game.
Yeah.
So there are certain people in the mines who want as much data as we can give them, gigs and gigs of data, and they love it. But then you get to some other levels, and they have a few choice letter words for the type of data that you're sending them. So I think that's sort of a broad question in the sense that, again, some departments probably need it more than others. But right now, the overwhelming amount of data that's being given to companies, I don't think anybody's ready to ingest it all, to be honest with you.
No, that's the biggest thing that we're seeing. Yeah, exactly echo what Raffi said. There is absolutely different levels, and it all depends. When you have champions of the technology, such as like Iain, for example, he's been pushing the adoption of different technology and giving like different companies the opportunity to basically put their money where their mouth is and show what it can do in a real world environment. And that's a big part of it. But there's a lot of other times where the technology was kind of overhyped years prior. So I know coming in when I started the company, there was a lot of, yeah, we've had drones here before, they don't work, kind of go away type thing. So it really depends on the person that you're talking to within the operation, their willingness to be open to the idea of changing their workflow. Because again, you're dealing with human beings who typically normal people, once they have their workflow, they're pretty comfortable with that. They don't want to change. So unless they have incentive or there's a reason or you're going to make it better for them, they'll stick with what they're doing. They'll keep stubbing their toe. So it really depends. But again, to touch upon the data side of it, everybody who does want this technology, and you have your couple champions who understand the technology, but those people, because mining is full of opportunities for a lot of people who are willing to advance themselves and take the next step. Those champions typically are the people who will then move to the next position, who will be in a different role with a different company. So that momentum within that organization gets lost because that person understood the data, and with their loss, to bring somebody else in who had their same energy is sometimes hard to find. So you can have operations that were the biggest adopters that 6 months down the road are using it once a month when they're going from using it once a day. But again, it boils down to the data, and if they're capturing it but they're not utilizing it, they're not taking full advantage of what's there.
Great. So
I like your.
go ahead, Iain.
So I like your comparison of the people. As soon as you mention the data hungry people, I visualize faces in my head. And if you take for example, in our world, the dumping reams of data onto geotechnical engineers, they're just happier than they could ever be, but it's sort of only consumed in their own heads, in their own world. But the real big where the rewarding reactions were where in the case, I'll use a case example, being able to take that super dense scan data and turn it into factual information about the protection level left in the ground support in areas where people working and be able to show them. That's taken someone whose perspective of that science was, seeing your geotech go down and lick the wall and then tell you how safe you are, into something where there's actually a number there, and a 3D picture that shows you how much work we put into making sure that you're safe. That was a really big step change that I think I saw some reactions I was quite happy with.
Fascinating. So, guys, just taking a bit of a step back here, what are some real success stories we can look to so far in this process, more recently, of course, of digitizing the mine, particularly in the context of scanning technologies and remotely operated platforms? Does anybody have some really sort of awesome examples where these implementations went really well and were very impactful?
There's the big ones that kind of stick out to, at least for myself. We do a lot of them, but the more challenging ones are the vent raises and shafts. So a lot of the vertical structures, because they're typically not supported. So we did a project just recently where a mine basically wanted to, and this is where we're really promoting operations, when they ream or they drive a new vertical structure and they know that they're not going to be supporting it. When they have material that's reporting down at the bottom, their vent techs or their geotechs just make note of it, and it's like some material came down. But if you can tell where that material came down and you can measure and you can analyze and you can follow that, basically the formation of your problem, that's huge for the mines, because you could potentially get a remote shock creator into that area, and it's going to be a huge cost for the mine, but not as big of a cost as it will be if they lose that raise and they have to ream a new one. So if they don't have that information, they're just looking at rocks at the bottom of an opening at the end of the day. They know something's happening, but what? And so for us to be able to give them that information and show them, give them a baseline, and then when material does report at the bottom or they have a seismic event, something happens and they see a change in their flows, whatever the case may be, they can call us in, and within half hour, an hour, you have that information. You can then to do the comparison, it takes more than that, but to be able to tell very quickly that your 3-meter raise now has a huge chunk missing in it, you can tell that pretty much right after your scan's completed. So they can action upon that. And then when you get them back their data where you have the change over time comparison, all of that, you can see if there's convergence, you can see where it's sloughing, and you can pinpoint all of that. So that information that they're getting, a couple of years ago, it was all guessing. It was like, okay, well, hopefully this thing doesn't peel anymore. And now they can at least know where it's peeling and know how they're going to address it, line it up with their geology and their lithology, and kind of go forward from there. So it's kind of a generic example, but that's been one where it's been a ton of value for the mining operations in a way that they couldn't get that value anytime before this technology, essentially SLAM technology, was out.
I'll echo that one. I think just to reinforce the point, because our our journey, where I started with trying to get the scanning technology into remote places, the ultimate goal was, ore passes and vent raises, these really challenging structures for exactly the reason that Matt has mentioned. And they've been the last to be practical to do with the technology. They're there now, but it really spoke to how challenging those places are. They're small, they're difficult to get a signal into. Sometimes they don't have the same texture in them to be able to track. They have air currents and dust and so on. So it's really the full set of challenging environment when it comes to remote inspection.
Matt, do you want to share a little bit of the work you did for us when we dropped the bucket down the shaft and really didn't know what the shaft looked like afterwards?
Yeah, I don't have anything prepared, but I can definitely speak to it. That was actually a really good use case for the technology. So for that one in particular, I'm really proud of my guys because Mine Rescue is an amazing group and they're always ready, and that's kind of their motto. But for us to be able to get out to site and start collecting information and have and basically eyes on the problem before Mine Rescue even arrived on site was a huge win for us. So that ability to deploy this equipment and how quickly it captures is massive. So for that particular case, to be able to identify what the problem was, what was going on, and then to be able to monitor it to make sure that it wasn't shifting, that it wasn't going to become a bigger problem than it was huge. And then to be able to monitor the progress on the rehabilitation, to be able to kind of check in on the mine down at the bottom of the shaft to make sure that everything's working as all their control board is saying, because they couldn't get anybody down there, was I don't know what the value was for you guys, Anthony, but I imagine it was quite significant.
And it was data that we wouldn't have been able to get that situational data and the change over time in any other way, right? We would have still done the job safely, but not having that data to kind of drive our decisions and validate decisions that we were making was really invaluable with both how quickly we were able to react and how successful we were able to do that rehabilitation, for sure.
Yeah. Yeah, no, it was good. We were able to turn around basically screenshots, and I have to give a huge shout out to Lori because that was all her. My technicians did an amazing job. They were on site, but the imagery and the visuals, and to be able to give them exact depths where they needed to start addressing, because they were able to start planning how they were going to rehab this before we even had the bucket hooked up and out. They were already kind of looking at how they were going to address it, and to be able to have that level of information and that um, just that quickly was kind of was unheard of at the time.
Maybe I'll take a moment to throw something about very harsh environments, because I think that's sort of something that we're starting to toy with, and the emergency response aspect there. I also chair the advisory committee for mine rescue in Ontario, and we have a standing item around remote inspection tools for emergency response. And we've seen a couple really interesting applications, like the example you're talking about at Vale. We've seen a couple examples of machines that have fallen in very difficult scenarios that need to be extracted. Um, but we hosted a challenge recently where we set a fire in a simulated underground. They simulated a underground construction project to be able to invite technologies in to test the ability to travel through fire, to go and look for people on the other side of that type of scenario. And we saw some uh, signs that the technology is close to being able to deal with those kind of environments. So I think it's good opportunity to flag where we're still looking at it. I know there's a lot of focus on how remote technology can work um, in flammable environments or gas environments or radiation environments, but to operate on the other side of a fire is could be a really big space that remote could work in.
So Raffi, I don't want you to give away who all your clients are, but I'm sure you've had some success in this area. I think what you see mainly is the adoption of, of new technologies, in particular Exyns. So, I mean, if not in detail, can you talk generally about how that usually goes?
Yeah, most definitely. I mean, it's no secret. Probably the gentlemen who are on this panel all know who our clients are. Some of them are our clients, and I mean, Matt and I definitely know each other's clients, so there's no secret there. But I mean, again, most of the adopters have gone basically towards the basic original stuff that we talked about, just the stope mapping. However, that graduated to after the stope mapping for extracting. People started talking about dilution. So then we were able to get mine managers and mill managers actually starting to talk to each other because we could figure out a little bit of dilution. Then, of course, backfill started coming into it, and then some of the larger mines, which with really, really big stopes, who traditionally they use the old CMS from the top to say, "Oh yeah, we need this much backfill." Calculations, of course, were well off. So a lot of the mines started adopting it for that type of stuff. But where it got really, really interesting, and Iain touched on it now, I've had the privilege of presenting this to the International Mine Rescue Board and a few of the others. There was an incident in Ghana a couple of years ago where, there was unfortunately collapse, and we needed drones there basically overnight. And we were able to get down there and map an area which would have previously been impossible. And there's a very good chance everybody on this panel has seen this video. But it was a 2-level collapse, and the mine rescuers were able to, get this data within 6 to 7 minutes. With a completely autonomous flight, they were under fully supported ground, so at no point were they near the danger zone. And for us, that was key to be able to grow our footprint with different use cases. I mean, at the end of the day, again, I think we led this off at the very beginning saying, the most important thing are our miners. So the use cases will grow. I mean, we've had super interesting stuff where we've gathered data in phenomenal places, again, just like Matt's team has done. But when you could start really getting the same tool and it starts becoming your Swiss Army knife, where you could use it for not just gathering data for production, but helping out the mine rescue team and potentially helping out the supply chain team with georeferencing and things of the sort. There's a lot of cool use cases out there.
Awesome. So conversely, I want to ask about maybe some unsuccessful examples of an attempt to implement a new technology. So personally, I have one example. We tried to basically implement a drone-based scanning platform in a potash mine where there is very fine corrosive dust, and it's impossible to use water to suppress the dust because that would ruin the product. And so it turns out there is way too much dust to make this work, and that perhaps was obvious to begin with, but we are now the wiser for having tried that. So guys, any examples where things didn't go as you would have hoped, and any little sort of lessons gleaned from that?
I can definitely account a few. The biggest thing, I guess, the bigger takeaway, without going into talking about the many crashes that we've had with all of our different systems, we operate in a very hostile environment, so it's kind of expected that at some point it's not a matter of if it goes down, it's just a matter of when it goes down. But what we find is our biggest things are usually environmental. Um, Environmental is a big one, and smooth environments as well play a big factor in a lot of things. So that's, I guess, maybe that's one that I can share where it wasn't a loss of equipment and there's no other story to it. But the one limitation that we see with SLAM technology is really smooth areas. So pen stocks, freshly lined shafts, stuff like that. That's the one thing where a lot of clients kind of have really high expectations, but not understanding the technology and the limitations. We need features. This is essentially our biggest thing. But when we're in those areas, it goes to environment. So like you touched upon, Fraser, the high dust, even if it isn't potash, you can get into areas where you're basically completely obscured. The drone can dead reckon itself back to its launch point, but you're not collecting any data for the client. And then there's water, I guess, is the other big one. So both, whether you're running an RGB visual sensor or you're running LiDAR, when you get into certain thicknesses and certain amounts of water vapor, that actually has been probably one of our more difficult things when we run into, is you run into a super foggy area or you run into a fog layer inside the stope. Things like that kind of lead to unplanned outcomes when you get into stuff like that.
Unplanned outcomes. That's a good euphemism. We'll use that one here at RMUS from now on.
You're welcome to it.
Yeah, I think there are probably stories, especially in the early days, just when people weren't ready for the technology, and for the most well-intentioned train the trainer programs, they're bound to fail. So we actually had a customer, not to be named, uh, who just basically, I mean, this was a few years ago. They wanted to take the exact same technology that we were using for the underground and use it for the surface, but without changing the settings. And as you could imagine, this drone took off on them. The interesting thing is, we got a lot of good video and data from it. We found it, but again, I think misuse of equipment is probably one of the things where, because these robots can do so much, sometimes customers are just testing the limits a little bit more than they should. But uh, it was great. Nobody got hurt. We didn't fully lose the equipment, just some minor repairs. But I'd say that there was one. You could chalk that up to a bit of a fail.
I have an interesting story about the substitution of technology with people when it comes to failures. We discovered this with our first autonomous machine, which is not what you might expect on this call, but our first autonomous machine was a 14-ton loader. So we were one of the early users of primitive automation on autonomous loaders. One of the challenges of ultra deep mining, of course, is temperature. Even in the north, we're dealing with 20s and 30s in terms of temperatures underground. And one of the advantages that we saw with remote inspection tools was that they don't experience heat stress. But if you're a mechanical engineer or an electrical engineer, you can kind of see the hole in that logic. So our loaders experience heat stress too. We in the aforementioned mine rescue emergency response test, we caused Spot to experience some heat stress and take himself out of action. So this is those are unexpected failures of substituting people for machines and not realizing that they still have some of those, they still experience some of those limitations, and they have to go back into the to be improved bin.
Not so much an operational fail, but certainly an interesting media. I remember picking up the local paper up north one weekend with an alleged spotted around town with a mystery person driving it, and there was all sorts of comments on Facebook and Twitter about what was going on and where was this spot coming from and what did this mean for the town. So certainly, hobbyists out trying the technology early on the weekend downtown can certainly cause a lot of speculation and a lot of media attention.
Definitely, and certainly none of us would associate with such a person. But it raises the point that, sometimes there are, maybe we call them PR implications to these implementations. So that's very interesting. And that case in particular was strange to learn of the impact that something like that can have. But
It
important
actually
nonetheless.
worked out. It did work out kind of good because it did get a lot of attention to Spot being up in the north at the time. So
Indeed, that is a good point. So just for fun, I've got a question that's mainly directed at Matt and Raffi. What are some of the most challenging environments that you've been able to access and scan? And I'm not referring to like bad hotel rooms or anything like that. I mean operationally. You guys have both talked. Well, I think you both talked about some of the types of environments that are sort of more challenging for the technology. But I mean, do you have any specific examples that were rather impressive?
Yeah, two come to mind. I mean, again, the first one, as I mentioned, was the one in Ghana, and I wonder if I could screen share here. Are we able to do that and show video just to see? Because
Thumbs
I
up
mean,
option.
let me quickly see if I can do this. Because like this would be a pretty, yeah, let me see. Let me know if you could see this.
Yep.
We do see it.
All right, let me just play this. And so this was the mine rescue operation. And now bear in mind, this has been sped up 4 times. Now, this is a completely autonomous flight. So up until this here, it's pretty easy. Once it takes this hard right here and goes over the barrier, you could sort of get an idea of the area that we were dealing with. Now, this isn't something that you see in a mine every day, obviously. And this was done, again, completely autonomously. At this point, we lost full connectivity with the robot, but it was able to navigate, through everything realistically. So you had a whole bunch of ground support. You had an immense amount of dust, which we cleaned up, obviously, for this video. Um, but this complete flight, and this isn't completely autonomous, so AL4 mode, so we're not giving it a point-to-point mission. We're basically giving it just a complete area. And it was able to go and map this area, again, in just under 7 minutes, navigate its way through all the collapsed area, the ground support, and then when you go back and see where the mine rescue team is standing, and you'll see it near the end of this video, um, a couple hundred meters away under fully supported ground. I'd say this was one of the more impressive things that we've done. Again, given the fact that we didn't have to get close, we didn't have to do any sort of remote takeover or anything of the sort, and the data was basically sent to us immediately. That's probably one of the most challenging ones, and I'd say the other one was probably up in Alaska, where one of our customers, even though we told them, don't fly this thing over water. I mean, at the end of the day, we're all dealing with more or less the same Velodynes, or the same type of pucks anyway. So whether it's Ouster or Velodyne, it's more or less the same. Um, but this customer flew 4.5 minute mission over a completely flooded area of the mine and then sent me the data and sent me the video. So they had 4K video of it, of course, and they were boggled as to how they were able to do this flight. Now, what they didn't know that I was more impressed than they were because we were sharing this internally. But I'd probably say those are 2 of the most difficult areas that we were able to get complete data from, again, without any sort of manual intervention.
That was extremely impressive. Can you give us a sort of a sense of the scale of that video you showed? Like what was the like out and back distance of that mission?
You're probably looking at about 300 meters out and 300 meters back. But it wasn't the distance that was the challenge. It was because it was multi-level and it had a lot of different areas and crevices that were created. And the way that our AL4 autonomy works is until it maps the entire volume, it doesn't come back. So a lot of the times when you send it out, you don't actually know how long it's getting out there for. So it could be, 2 minutes if it's just a basic in and out mission of a stope. But something like that, again, just under 7 minutes, you're flying at just over 2 seconds, 2 meters a second, to be able to gather that level of quality data. But yeah, I'd probably say that was about a 300-meter flight each way if we're going as the bird flies.
Very cool.
Yeah, that's impressive. Yeah, we've done obviously quite a few similar ones. Probably the ones that jump to the top of my head would be when we flew the super stack. So being able to map the interior of the super stack in Sudbury, that was a 1,200 foot tall stack that we were able to map the interior, and that one is actually the reason that one's kind of actually sits on the top of my head because that was a steel lined chimney, so super smooth, had all the like things that you would normally not do in the flight. Is kind of like, it's like, okay, well, this is the only way to get this information, and thankfully on that flight we were able to get it all out. The other ones are very similar to Raffi's, not quite on the extent, but a lot of mine rescue type or post-incident mapping and investigations. So those ones are usually the most challenging because you're going into a completely unprepared environment, which we're typically used to going into. But after an incident, you typically find a lot more dust in those areas. You find a lot more hanging material that's hanging down from the back or from the ribs that got blown across. So going into those areas, typically we're going in with one or two different pieces of equipment when we're going down, just because we don't know necessarily what we're getting into. But yeah, there's another one was when we had our drone buried in an active stope that was failing. That one, essentially, the short story of it was failing towards one of their main vents, and had it failed into that area, it could have potentially shut the mine down. So the value and importance of finding out what was going on in that area was huge. There was no cost at that time for that equipment that didn't outweigh the life of the mine, obviously. So that one, we show up and we're watching chunks falling in the stope, like in front of us. And I talked to my contact and I'm like, I'm going to lose my drone if I fly in there. And his honest to God response was, he looked me square in the eyes and was like, yep, probably. And it was just like, okay, well, I guess I'm flying in there. And I'm like, there's going to be, if it gets taken out, there's a replacement cost. He's like, yes. Do you know how much like potential value is in there? Not just on the sake of the mine, but just in this one stope. He's like, I will keep sending drones in there, as many as you have, until we get the answers. And it's like, okay, well, that's about 4, because I only have the 4 drones on the shelf, so we can do this 4 more times. But unfortunately, when we did fly in, a large chunk did come down, completely took out the drone. But the value was that we had the live model coming back across. So although we didn't have the high resolution point cloud, the full density, we had that live model. And from that, we were able to basically determine that it was actually breaking the opposite direction than the geology was telling them that they expected it to break. So for that, we were able to monitor that over the life of that particular stope, just to keep monitoring it. But that's kind of one that sticks on the back of my head. And that one was actually a drone that was like fresh out of the box, brand new scanner. It's literally its first flight and its first scan was its last. So that was a pretty memorable one.
Awesome. So now I just want to give the audience a chance to ask some questions. We have about 10 more minutes, so we'll see if we can have some questions come in for anybody here on the panel. While we wait, I've got one for Matt. Matt, tell us, is there any type of platform that is best to access difficult areas for scanning purposes, or does it depend? Can you tell us about that?
Yeah, no. So there's no all-in-one solution. I wish there was a Swiss Army knife of drones, but unfortunately there's not, and for good reason. We actually touched upon this a little bit earlier, but the big thing that mines need to understand is that all their different equipment they use, from their haul trucks to their scoops to whatever, they're all different manufacturers, and that's for good reason. Each manufacturer has its own specialty and its own, I guess, strength, as well as their own weaknesses. So it really truly depends on what they want to use the equipment for. So if they're going to be flying into just regular stopes, the 2 products that jump to mind are obviously the MSN system, and Raffi will put his hat in for the Exyn system. Those are going to be your 2 main ones for your autonomous stope navigation. Now, if you're needing to get into some of those tighter areas, like your bins, chutes, ore passes, things like that, then you're going to be looking kind of towards your Flyability Ilios drone. You have a cage around it. The new Ilios does have a scanner. You're not going to get the same coverage that you're going to get with an MSN drone or an Exyn drone as far as just range, because it is still tethered to the pilot, in the sense of you still need to physically command the unit. But for a lot of the areas that the mine may need to get into, that may be a more suitable option. So it really depends. If they're a narrow reed gold mine, I would say Ilios all day. If they're a large nickel mine or copper mine, like Iain's zinc mine, I'd be saying one of the autonomous systems is going to be your better solution, because you're going to get that full coverage in those areas. So yeah, it really depends. And then if you have other areas that you need to explore, there may be some ground-based options that might be better suited.
Great, thank you. So we have quite a good question from the audience. What sort of communication do we use when working in mines? And Robin is asking this mainly in the context of Spot, which is good because with Spot we have many options. So I'll kind of try to start an answer here. Spot gives us the option of using many different mediums of communication. If the facility has Wi-Fi, that would be a good option. Or LTE. This would also be a good option. The robot has the option of using an LTE module. If we want the system to be more self-contained, perhaps for like a mine rescue type scenario, we might think about using a mesh radio network like Ragent or Persistent Systems, and just have a node with the operator and a node on the robot. Could anybody maybe elaborate to that answer?
Yeah, so I'll just speak to some of the products we use. So for Spot, you're absolutely spot on. You can tie it into pretty much any of your networks. If you have a network down there, you can run a mesh. For the drones, they're pretty much operating in either 2.4 or 5.8. You can tap them into LTE as well if you like. So you can put a LTE modem on there. So a lot of the mines are going that route for the last mile in their operations. So yeah, it's pretty much, I would say, I don't want to say the sky's the limit. There are some limitations, but the radio communication manufacturers that are out there that are working specifically in mining are working for options to be able to be used with these remote systems.
Awesome.
Yeah.
And then sorry,
No,
go
so
ahead.
I was just going to add that obviously also once you get sort of to the last mile, you can go fully remote where you don't have any communication. So a lot of the newer equipment that's out there, and again, obviously as I work with Exyn, I'll talk about that. Um, you're working with a tablet, but at a certain point, it will lose communications, which is fine. So at that point, the robot does not need any sort of communication, whether it's with the tablet, the remote, or anything whatsoever. Everything is contained into the drone, into the robot itself. And then once it comes back within comms range, it dumps the data. So that's where you get the full autonomy from.
Right. So essentially, autonomous exploration, sort of like you described with in the video that we saw earlier. And I've heard that hypothetically this may also be possible with Spot at some point in the future. Is anybody allowed to comment on that?
For which, sorry, Fraser?
So autonomous exploration will be an option on Spot. Maybe I may have heard something like that.
Yeah, so
So that
Emicent is, as well as AutoMap. They're another organization using SLAM-based scanning. So they are participating in the DARPA subterranean competition. So they have basically a bolt-on payload, and I believe Leica does as well. I'm not sure the limitations or capabilities of that system, and if it's currently commercially ready. But I know I've seen a bunch of trade shows with them walking around with their scanner on it.
And certainly with the one of the spots that we've got, we're certainly looking at having it operate in and out of network coverage. So it'll start in network coverage. It'll do some of its work in a black spot, and then as part of its journey, come back into network coverage again. So we believe we can successfully do it without needing continuous network coverage the whole route the robot will be doing its inspections on.
Yeah, there's an important point in there that Raffi mentioned. You mentioned part of it, kind of connected to what you're saying, Anthony. Right? It's important for people to understand the role of automation in the communication space too. Automation gives you, we think of full automation, but automation gives us the ability to live through connection latency and/or blackouts or blind spots, and give the equipment the ability to either survive them or come back from them or pass through into another area or complete the mission. So even if someone's not really thinking that they want to do completely autonomous missions, the automation features are important for that aspect. and really you're going to want those features anyway, which takes up a lot of the stress of having a really good control link. That's yeah, just an important point for anyone looking at the technologies.
Agreed. Well, thank you guys very much. We're coming up to our time limit here. So thank you to the audience for joining us. Thank you very much to Anthony, Iain, Matt, and Raffi for joining us to contribute today. Remember to join us for the rest of our RMUS Tech Week sessions, and we'll see you then.
Bye, everyone.
Thanks, everyone.
Yeah, cheers.
Thank you.